Hello, my name is Ronnie Manning, Yubico's Director of Public Relations. Today's webinar, Integrating U2F from Concept to Implementation, will be presented by Dane Nilsson, Yubico's Engineering Lead. The presentation will run for about 45 minutes with a Q&A after. To submit questions, please locate the question box in the GoToWebinar control panel. Thank you very much for your attendance today. Dane?
My name is Dane Nilsson. I'm the engineering lead at Yubico, and you can reach me at the email address below. So let's start with a quick reminder on what U2F looks like to the user. So you visit your site. For instance, this is taken from GitHub. You enter your username and your password. You click on Sign In. Then you're prompted to insert your security key, which you do. The button starts flashing. You touch the device, and then you're logged in. So there are quite a few benefits of using U2F over other two-factor authentication solutions like OTP. One of the main ones is the heightened security it gives you. So only U2F is able to give you this protection against both phishing and man-in-the-middle attacks. And phishing is a huge problem today. It also lets your users use a single device with many different sites, and it kind of moves the device provisioning to the user's end of things. It's the bring your own authenticator model. And this makes it much cheaper to deploy for you as a site owner. You don't have to worry about the hardware. And lastly, it's based on open standards, and there are a lot of large actors behind it. So there are several options for devices, software, and services, so you're not locked into a single vendor. Now, today I'm going to assume that you have an existing site and you want to understand more about U2F, how it works, and what you need to do on your end to start supporting U2F. So we're going to look at some of the core concepts, what you need to understand, look at actual code on taking a service without U2F and adding U2F support to it, and I'm going to show you some links to some resources where you can get libraries and services and documentation and things like that. So let's start out with one of the concepts that we've seen a bit of confusion surrounding when people start trying to implement U2F, and that's that there's this thing called App ID. Now, the reason we have an App ID in U2F is to eliminate phishing. An App ID is an identifier for the service you're going to use. So this could be Google or GitHub or Dropbox or something like that. And since we're using a single device with multiple services, we're still using separate credentials for each service, and each credentials needs to be specifically locked to that very specific app. And we use the browser to verify that. So we've got some examples here of URLs. You can see this first two, assuming we have a credential that's valid for https://example.com. These first URLs are perfectly fine for that. However, there are two examples of bad URLs. The first one clearly has the wrong domain, in which case the browser won't let you mistakenly use a valid credential for this bad site. And in the second case, the domain is actually correct, but the protocol is different because it's not using HTTPS. So this is how U2F is able to eliminate the threat of phishing. So what is the actual app ID? Well, in the simple case, it's just the valid origin. So the protocol, the domain name, and optionally the port number if it's a non-standard port. You can do more advanced things. You can have the app ID be a URL to a file that describes the valid origins, but for most cases it's fine to just use one origin. It's typically, unless you have a bunch of subdomains and more complicated structures, then that's the best way to go. And we're going to assume that today. The next concept we're going to look at is the key handle. Now that is used to identify a specific credential. Again, because we have a single device that has multiple credentials, the server needs some way to say, okay, I want to authenticate this specific credential for this specific user. So every time you register a U2F device, that's you go to the security page, you click on Add a Device, and you touch the button, that will produce a new credential with its own key handle. And each time the service authenticates a user, the server will pass the key handle to the device, so the device knows which credential to use again. And each device, each key handle is locked to a single app ID. Now let's take a quick look at the different parts of U2F. Beginning on the user side, you have the U2F authenticator. That's the hardware device, your YubiKey. It has a little button to prove that there's a user there intending to perform some action. Then it has a secure element, which contains all the device secrets and performs all the cryptographic functions, making sure never to leak any of that secret information outside of the device itself. And then you have the USB transport. This is the USB connector that you actually plug into a desktop computer. Then you have the FIDO client. When we're talking about web, we're talking about a web browser that has FIDO support. Currently, that's the Chrome browser. The browser that is FIDO aware has code to communicate with the USB device over the USB interface, and it provides a JavaScript API for you to use on your site, which brings us to the last part, which is the server side of things. So you have a web application, and the changes you need to make that U2F aware is, well, changing some login flows, but you need to perform a bunch of crypto operations on the server, and to help you do that, we offer several U2F libraries, and there's new information that you need to store for each user, such as these key handles and public keys and so on. And those three parts we can look at again if we want to look at what actually happens between how they interact with each other. So there are two things you can do in U2F. You can register a device, that's assigning, creating that binding between your user account and the device, and you can authenticate a device. So that's when you're logging in to prove that you have the device. U2F is a challenge response protocol, which means that every transaction starts with the server generating a new unique challenge. And this makes sure that the response is locked to that transaction and can't be replayed at a later date or tampered with or something like that. So this is just a random number that the server generates. The server passes that as well as the app ID that we talked about. Both of those go into the browser. Now the browser looks at the app ID. Depending on its contents, it will look at the page that the user is actually on, and it will verify that this app ID is usable for this page. Now the browser will start to construct this client data object containing information about what the browser knows about. So the challenge that it just received, the origin of the page you're currently on, the U2F action we're performing, in this case a registration, state about the SSL connection, and then it will take that object as well as the app ID and pass both of those into the U2F device and say, create a new credential for this app ID. Now the U2F device, once the user confirms by touching, will generate a new credential. That's a private key and a public key, and it will create a key handle to refer to this credential later. Now the private key will never leave the U2F device. The public key and the key handle, however, will be sent back to the browser, as well as a signature of the client data. Now this is a cryptographic signature that ensures that the client data isn't modified when it's sent back to the server. So the browser just takes these things, the public key, key handle, signature, and client data, passes those back to the server. Now the server verifies everything that's in the client data, so ensuring the challenge is the same one it sent, the origin is correct. By verifying the SSL state, it can ensure that there are no man-in-the-middle attacks going on. And then it stores the public key and the key handle for the user. So the second action you can do is authentication, and it's very similar to registration. So remembering one of the first slides where we see the login flow, you start by entering username and password. At this point, the server knows who you are, but it needs to ensure that you also have the U2F device in your possession. So since it knows who you are, it knows it can look in its own database, get the public key and key handle for that specific user. In actuality, this is probably multiple key handles if the user has multiple devices. But as a simplification, we're just going to see what happens with one key handle. Again, it sends the app ID, a new challenge, and this time the key handle to the browser. And the browser verifies the app ID just as before, constructs the client data just as before. Only this time the action is authentication instead of registration. And it passes the app ID and the client data as in registration, but also the key handle to the device. And now instead it says, authenticate this client data using the credential defined by this key handle. The U2F device will then look at the key handle, make sure it recognizes it, make sure that it's valid for that specific app ID. This is what I talked about earlier about locking credentials to a specific app. And if those match, then it will use the private key to create a signature over the client data. And that signature will be passed back to the browser. The browser will pass it along with the client data to the server. And the server, again, will verify the contents of the client data and verify the signature. So how do you actually do the server parts of this yourself? I mean, what the browser implementation is already done out of your hands. That's in Chrome. The device implementation, well, we provide that. So what you're probably going to be looking at is doing the server end of things. And you can do it yourself, or maybe not completely yourself, but using some of our open source libraries that we provided and that third parties have provided. They'll handle all the crypto parts for you, verifying those signatures, and what's left for you is modifying your login flow and handling that credential to user mapping. So this gives you the highest level of control. You kind of do everything yourself. You can modify the parts that you're using, the third-party parts. Or you can use our U2F Val API. And that takes care of, well, obviously not everything, but it takes care of a lot more than just using the libraries. And the reason is, if you look at U2F by itself, there's no concept of a user. So you have to do that mapping yourself with user to credential, having multiple credentials, keeping track of which challenges are valid, things like that. So we wrote this this API that we're providing as a service that you can use. Also, we have a standalone server implementation, but it provides that user-to-device mapping, and it has its own storage, so it lets you do this without touching your own database. It also provides you with some device metadata. And we're making this publicly available today. It's at an early stage. It's very good for getting started quickly and doing proof of concepts. And that's what we're going to look at now as I show you a tutorial and get our hands dirty with some actual code. So we're going to be looking at a project written in Python. There's a web framework for Python called Flask. You might be familiar with it, or you might not be. It's pretty lightweight, so even if you're not, that shouldn't be a big issue here. But it does ship with some example projects of its own. And this tutorial is based on a small Twitter clone that is part of that suite of examples. So we're going to base it off of that has a concept of users, it has username password authentication, and we're going to add U2F capability to that. Now, later on you can follow along. This repository is public. There are tags showing the different steps, but I'm going to go through them one by one now. Let's see. Now I've done some initial setup here from the original example from Flask. So it's been untouched from Flask here. I've added a git ignore file to just ignore some of the files that I'm working with. I've added this requirements.txt file so that you can easily install dependencies. I switched over the internal server to use HTTPS instead of HTTP, which it did by default. The reason is that Chrome requires you use HTTPS for U2F. So we bundled a dummy certificate, self-signed certificate, which will you throw a bunch of warnings in the browser, but we can ignore those for now. I mean, on a production environment, you would obviously have a real certificate. It has the example has its own database for the user data and the posts, and I made a small change so that instead of clearing out that database each time you run the server, it's you have to do that explicit, so we can use this. We don't have to wipe the database every time we make changes. And lastly, I've updated the README with some information about this tutorial instead of the example. And this is going to be our starting point. So so far, there's been no changes made that affect the actual logic of the application. There's been nothing done to add U2F support. And while we look at the code, I'm also going to run this example. I'm going to start by running that database initialization. So we have a clear database, but table set up. And then run the server. So it's running HTTPS on port 5000. And we should be able to view that. There we go. So again, this is out of the box from Flask. There's a public timeline. You can sign up and you can sign in. So let's try that. Oops. Okay, created the user. Now let's log in. My timeline. So post a few new things. All right, so you can see it's a basic version of Twitter. If you go to my timeline, I see my messages, my posts here. The public timeline has my posts again because I'm the only user. I can sign out. Let's just create a new dummy user. So you get the point. I mean, this is a basic service. But the interesting thing is there is a sign out and a sign in, and a concept of being signed in. So let me sign out of that. And let's go to the first step of the actual tutorial. Now the first step we're going to have to do is we're going to have to add a JavaScript file called U2F API.js. This is the high-level API. So Chrome provides a low-level API, but we're going to want to use the high-level API, and that's provided by this JavaScript file. So this is something from Google that I've just copied into this project, so we're not going to look at that code, but that's been copied in. I've changed my core layout template file here to add a script tag including that, and that will allow us to call U2F.register as well as U2F.sign from JavaScript. So step one. So just verify that works. I'm going to refresh this page, and if we look at page source, yeah, so here's that script tag that I added. So that's the only change. Functionally, it's the same. So let's move on to the next step. go to step 2. Now we're going to add a client library for this U2F val service that I mentioned. So I've already installed the library, but we have to set up the connection. So first, I have to go to that service. You can see this URL later as well. It's going to be in the slides that we release. But here I'm going to create a new application. It's a little bit slow right now. Hopefully I'm not having network problems. Okay, there we go. Webinar tutorial. And here's the app ID, so it needs to know what the app ID is. Since I'm running this on localhost with HTTPS on port 5000, that's what I'm putting as my app ID, which will lock any credentials I issue to that particular domain. Okay, now I need to be able to access this application, which means I need to create an API token. So I'm going to do that. Call this mini-twit. And this gives me the secret key, so nobody copy this because it's my secret. Let's see. I'm going to put that in a text file that I have here with my server code. Oops. Let's see. Copy. There. Now let's look at the actual code changes. First we have minitwit.py, which is the whole application logic. I'm importing the U2F val client here, as well as the API token method of authentication. Setting up some server settings, so this is the endpoint to the API. I'm opening that file that I just wrote, reading the contents, removing any white space, and saving that into a variable called U2F val API token. Otherwise, if that file can't be opened, throw an error. And then down here, I'm setting up a client to connect to that endpoint using the API token that I stored there, and saving a reference to that as U2F val. So we're going to be using this little variable a lot throughout the coming code. And if I check out that code, I mean, we could look at the page. We're not going to see any difference because we're not actually doing anything with that, but we're setting up the connection behind the scenes. So instead, let's go to the next step. So now we're going to add a security page. So we need a page where users can manage their security keys. In the application logic, we're adding a new route here for /security. So if you go to our page /security, it will run this part. And the only thing it does now is it renders a static template called security.html. Here's that template. It's very simple. It extends our kind of base template. It has a title, security settings, and it prints out that title, and it says you have no U2F devices registered. So this is hard-coded right now. And in our main layout, for the logged-in user, we're adding a link in the top menu that says security. So this should actually give us some changes that are visible. We'll jump to that part of the code. It was only for registered users, so I'm going to sign in. And here you can see we added this little security item in the menu. And if I click on it, security settings, you have no U2F devices registered. So that works. It's not very useful yet, though. And here we go. Next step. U2F device registration. So we've talked about what this is. Now we're going to look at the code to actually do it. we need to allow the user to register one or more security keys with their account, so to bind them to the account. The first thing we've done in minitwit.py is create a new function called getCurrentUser. This is going to verify that the user is logged in. If the user isn't logged in, we're going to just show them an access denied page. Given that he is logged in, it's going to return the user ID. Now, U2F val needs some way to associate credentials with users, and it needs a unique string for each user. So that's the identifier for that user. Flask provides us with a numeric user ID, so the only thing we're doing here is turn that into a string. We could also use the username or something, but it needs to be something that never changes. So maybe our application has usernames that can change. In that case, better to use the user ID. I'm going to come back to this code. We'll skip ahead a little bit and do it in a more logical order. On our security page, under the box that says you have no U2F devices registered, I'm going to add a new box that says register a new U2F device, and it's going to have a form. That form is going to post data to U2F register, and we're adding a field called name that will take kind of a device nickname, so you can differentiate between your different U2F devices, and the little submit button. So on the security page, you'll have this form. You enter your name, you click add. That's going to submit to U2F register. So let's look at that code. So we've added that. That's new. That will use this U2F val client and call a function called register begin using our getCurrentUser function. So we're telling the service now that we want to create a new U2F device registration for this user. And that's going to give us back a registration request that contains everything we need to make the browser happy. So then we're going to render a template called U2F add. We're going to pass in the name, that was the nickname for the device, and this registration request that we got from U2F val. So let's jump to that template. This is a new template. It extends the base layout. It shows some text here. It says insert and touch a new U2F device. And then we add a form that posts to U2F register complete. Now we have two fields in that form. One is, both are hidden, so this form is invisible to the user. But one contains the nickname for the device. This is just a way to kind of keep passing that along. And then we have an empty field called U2F data, and we're going to populate that field before we submit this form. So the next part is some JavaScript that we're including on this page. And now we're using the U2F high-level JavaScript API. So we're calling U2F.register. This tells the browser to do all the parts that the browser does, including interacting with the user, having the user touch the device, and then it's going to return the response with the public key and the key handle. So we need to pass two JSON objects containing those things that we needed, which is the app ID, the challenge. There's some other stuff in there. And then it takes a callback function. So because we're using U2F val, we don't have to really bother with what's in here. Both of those parameters are just parts of this registration request that we got. So U2F val takes care of that for us. We just need to serialize it to JSON. And lastly, we provide it with a callback function. So when the browser is done and the user has touched the device and the device has created the new credential, we'll get all that back in this resp object. We'll do a quick check to make sure there was an error, but assuming that everything went fine, we'll pick out this form element, we'll convert the response into JSON and set the value and then submit the form. So everything the browser API can get back here is sent back to the server. So that will go to U2F register complete, which we have up here. Again, we're just going to use our U2F val client here and say, okay, now I want a complete registration for the currently logged in user. Here's all that U2F data that the browser gave me, and I want to set a property on this device, give it a name. So this is our nickname here. and then I want to forward the user back to the security page. So let's take a look at this in action. So here's the new box that we added. Let's try to register a device. I have two keys inserted on my computer. I have a blue one and a black one, so I'll differentiate them by color. Add my blue key. Now, this takes us to that U2F register endpoint. It says insert and touch any U2F device, so I'm just going to touch the one I already have inserted. And I'm back to security settings. Now this still says you have no U2F devices registered, and that's because this was a hard-coded string. We don't actually have any logic to show me the U2F devices. But to show you that it actually was successful, I'm going to switch back to the interface for the U2FL service, refresh user stats, and it actually now tells me that I have one user and one registered U2F device. So it would be kind of nice if the user could see this too. So let's jump to that step, which happens to be the next one. So now we're going to list registered devices. So it's not just enough to add devices, we have to be able to see the devices. And since we get some nice metadata from the service, we might as well show an image and a device name, things like that. So we took our old static security page, and now instead we're going to modify that, but we're going to make it a bit more dynamic. So we're going to start by using our U2F client. We ask it to list devices for the current user. We get that back. And then we pass those devices to the template. And here's the update to the template. So where we previously just said you have no U2F devices registered, we will now loop through each of these devices, and for each device, print out a line with an image. So the device has metadata, metadata about the device and the vendor, but we want an image for the device. So we'll show that there. The device has a few properties. Those are the ones that we added. So we added a name property. That's the kind of nickname, Dane's blue key. So that's going to be printed there. And the device itself has some metadata about the display name, what type of device it is. So we'll do that for each device. If there are no devices, we will still show you have no devices registered. And looking at that in action, there, I can actually see my device. And I can add another device. And you can see that one as well. All right, let's move on. So the next step will be U2F device removal. So maybe I've lost one of my devices, or I just don't want to be using it with the service anymore. So this will allow the user to deassociate a previously registered security key from my account. So this is very simple. In the template for the security page, in that loop that shows each device, we're adding a link. It says remove. It's going to open up the U2F unregister page, which we haven't added yet, and it's going to pass handle equals device handle. So each device descriptor that you get back from the list devices command has an ID to refer to it. So this isn't the key handle itself, but there's a one-to-one mapping between this U2F val handle for the device, for the credential, and the key handle. So you can think of it as the key handle. In our program logic, we add this U2F unregister page that takes the handle. We use our U2F val client again. We say unregister, pass in the current user and this handle. And this will, of course, make sure that the user we're trying to unregister the device for actually owns that device. Otherwise, this shouldn't be allowed. So So we have that. And once that's done, we redirect back to the security page. So if I just refresh the security page, we see the new link. I will try removing one of my keys. Yep, and then it goes away. Now there's one step remaining. We've done everything we need here for managing our keys. So we can add keys, remove keys, and list keys. But we still haven't done any authentication. So I can still sign in with username and password, even though I have security keys registered. And that will be the final step for us to tackle. Now, there's a few different ways to do this, to model this. We're going to go with the same model that GitHub has or Google has, which is we're going to have U2F be optional. So if a user doesn't have a U2F device, well, they can just use username and password by itself. However, if the user has one or more keys registered, then it needs to be a requirement that when you log in, you have to prove that you're in possession of one of those keys. So our program logic is we have an import here because we're going to be catching an exception from the U2F Val client library. So we need to import that. This was the old, let's look at the whole there. So this is the previous code for login, which logs the user in. It takes a username and a password from the from the form that you enter, and it will pick up the user from the database and make sure that the password matches the one sent in. And previously what it did when those were correct is it would flash you were logged in, and then it would store the user ID in a session variable called user ID. Now this was actually, this in the mini-twid logic, this is what defines you as being logged in or not. So when this is set, it means that you're logged in, and then it redirects you to timeline. So this part we're switching out here. Instead of doing that, we are going to save the user ID. So at this point, the username and password has been approved, but we need to verify the U2F part. So we're going to save that in a session variable, but not the one that means you're logged in, just one that we can retrieve for later use. And then we're going to use our U2F Val client, and instead of starting the registration like we did before when you're writing a key, we're going to do the very similar but different auth begin function. Here I'm manually converting the user ID to a string. We can't use our get current user because we're not really logged in here at this point, so that would give the user an unauthorized error. But just like when we did the registration, we get this auth request object that contains all the data that we need, the challenge, the app ID, and so on. And we pass that to a template called U2F auth. Now, what's different here is we catch an exception called no eligible devices exception. And the reason here is that if you try to begin auth with a user that doesn't have any keys registered, then obviously that won't work because, well, the user doesn't have any keys. So in that case, the library will throw this exception, which we catch. Now, it could also be that the user has devices, but they're disabled for some reason. They could be marked as potentially compromised. We're not going to go into those details here, but there is such a situation. In that case, we'll just show that as an error. But the case we're interested in is if the user doesn't have any devices registered, well, then we treat authentication like we did before. So we tell the user he's logged in, maybe making this part of it more clear. You logged in without using U2F, so the user understands, hey, there's something to do in the security settings. But we do set the session variable user ID so that the user is logged in and redirect to timeline like before. So in the case that we do have keys, what happens? Well, we show this U2F auth page. And that's a new page, extends the base layout, looks very much like a registration page. Shows you insert and touch your U2F device. We have a form again hidden. This time we don't have the device nickname because we're not adding a new device, so we don't need that. And we have this little JavaScript snippet. So here we're calling U2F sign instead of U2F register. And this one takes a single JSON object that, again, we are provided via the auth.rec object that U2F val gave us. We just have to serialize it to JSON. And again, the callback function gets invoked once the user has touched the button, and this response needs to be passed back to the server. So assuming it's not an error, we put that into the form and we submit the form. This sends the data to U2F login complete, which then calls auth complete with the user ID, which we now get from that second session variable that we defined. We use the U2F data from the form that was just what the browser gave us, and we get back a device. And this device holds the metadata about the device, the properties, so we can flash a message that is kind of customized. It says, okay, authenticated using, and then the name that we set, which would be Dane's Blue key or something. And since in our application, setting this variable means that you're logged in, we need to do that and then redirect a timeline. So this might have been a bit much to go over, this last step. There's a few things going on, but it's very similar to registration step and similar to things that we've done before. And now let's test it out in action. So I'll sign out, sign in, my username and password. And now it's asking me to authenticate a U2F device. So I'm going to touch the flashing blue key, and it says authenticated using Dane's Blue key. And now I'm secured by U2F. If I were to sign in using the example user who didn't have any keys registered, you'll see that he just gets logged in without U2F. So shame on him. And that concludes the tutorial portion of this. So as promised, there are some resources that you can use. All this tutorial code that we looked at is available on GitHub using the URL right there. You can look at the different tags that show you step-by-step everything, how it's done. We have a U2F demo server that you can just kind of run your key against and see a little bit more information about what's going on behind the scenes. We have a bunch of libraries and sample code documentation on our developers website. We have this service that I've been using that provides me with the U2F storage and that U2F val service, the user mapping and everything and the metadata. You can go to utfval.appspot.com. That is running on Google App Engine. You can create an account and play around with that. Or if you'd rather run a standalone U2F val server yourself, that's also available on the final link down below. Thank you very much, and I think we'll move on to some questions. Okay, so the first question I got is, how many app IDs can a YubiKey support? Now, explaining it on this conceptual level, you kind of think that, okay, the device has to keep all these private keys in memory somewhere, as well as the key handles, and somehow verify that it belongs to the correct app ID. Due to how this is implemented, none of that is actually stored on the device. So each credential is recreated every time it's used based on the key handle. So there is a blog post on our blog where I go into detail on how this is done on a cryptographic level. But for practical purposes, this means that there is no limitation to the number of credentials you can have on a single key. So yeah, answer there is no limit. Question 2, is the app ID stored in the browser or on the U2F token? So again, I just said nothing is stored on the token. What is kind of encoded into the key handle is what app ID the key handle belongs to. So the server needs to know about the app ID, and the token conceptually needs to know about it, but it's not actually being stored there. The browser does not need to know about it. So there's nothing stored in the browser between sessions. Question 3, do alternative ports affect the app ID? Yes, they do. So the app ID, when you're pointing to a specific origin, needs to include the port if it's non-standard. So let me look at that. So when I registered this application here, I included the port because it's a non-standard port. If I were to try to access, if I were to access this on a different port, the browser wouldn't allow using this app ID. So it wouldn't allow using any of the credentials I've registered using this app ID. So there's a question about how exactly does U2F protect against man-in-the-middle attacks? And do we rely on the HTTPS certificate? So the HTTPS certificate is relied on for the phishing prevention, making sure that the app ID is only used for the endpoint that it's defined for. But the man-in-the-middle protection uses something called channel ID, which is a kind of simplified version of client-side certificates. When a browser makes a connection to a server, you do this handshake and you come up with a shared secret. And basically, by signing the client state, this goes into the client data that I showed, by having the U2F device sign that and send it to the server can match that against its own state. And if there were a man-in-the-middle attack, those two states wouldn't match up. So that is how it's protected. But if you want to look up more details, I would say look up client channel ID. There's a question about the high-level JavaScript API working with other browsers. The problem with other browsers is that they don't implement the low-level API, and the high-level API just uses the low-level API. There was kind of an experimental Firefox plugin released over the weekend that adds support for this. I'm not sure if it implements the full high-level API or if you need JavaScript for that as well. But that's kind of experimental. There are other efforts with at least Firefox to bring a more native support that I've seen. There's a very popular issue in their bug tracker. Other browsers, IE and Edge, I don't know what's going on with them. They don't offer support right now. That's all I can tell you. There's a question about IDP plugins for U2F Val and pricing. So right now, I mean, we're not charging for it. It's kind of a best effort service. We're not giving you any guarantees about it. I would recommend it for doing proof of concepts, things like that. So yeah, as I said, there's no charge for it. In terms of plugins, we really only have the kind of connector libraries that just help you use that REST API in a more easy way. We have those available for Python and for PHP. If you're using a language that a different language from those two, then you can look at the REST API specification. It's pretty simple. So you're just sending GET requests, POST requests, things like that, getting back JSON data. So it's a pretty simple protocol that does what it's intended to do and not much else. I've got a question. Does the browser do the app ID to origin validation, or is that the U2F device? So the U2F device doesn't know what page it's actually on, so that's the browser that does. The U2F device does verify that the app ID matches the key handle. So the key handle is locked to an app ID, and that's verified on the device, but we do trust the browser to verify that the page we're on is allowed by the app ID. There's a question about what is the best way to deal with non-U2F capable browsers or U2F capable browsers on devices where USB ports are not available, such as mobile. So I'd say go to those browser vendors and yell at them until they implement U2F support. That's probably the best solution. Otherwise, you can have one option is to have multiple authentication standards that you support, like you can do OTP via oath, and if users need to have other browsers, they can kind of downgrade to those instead. As for mobile, depends. I mean, we do offer devices capable of doing U2F over NFC. There's also a Bluetooth specification, but there's not much support on the mobile side for either of these yet because they're relatively new. You can always do a custom app for mobile that stores some soft credential, which actually could use U2F if you wanted to. So if you can't connect a physical USB device to it, you would have to use something other than that instead. So there's a question about supporting a timeout when we wait for a U2F token and touching it. I think that's up to the FIDO client. I don't think there's a way to specify a timeout yourself, but there is one built into it. So when you call U2F.sign or U2F.register, it does time out after a while, in which case the callback function gets called with an error code that means timed out. Okay, so there's a question about using U2F with non-browser clients, so native applications, mobile apps, command line tools. We have an open source Android app that does this. Let's see if you can find it. Let's make it up there. So this will use an NFC device, a U2F device that's NFC capable. It will authenticate against a web service. It doesn't use the browser. It's an app itself, so you can look at the source code. But basically, yes, that's doable. You need to implement everything that the FIDO client does, which is verifying the app ID, building the client data object. Obviously, some things might not be applicable in the same way when you're talking about native clients or something that isn't a browser, but it's definitely doable. And okay, so what happens if AppSpot is down? That's a good question. So if the service is down that stores all your U2F data, then those U2F val calls are going to throw an exception, telling you that the server is unreachable, and it will be up to your application logic to kind of figure that out. So either if you choose to lock everyone out, or you choose to kind of let everyone in. I mean, there are obviously problems with both approaches. If this is a big concern, then I would definitely suggest running the standalone server on your own premise or wherever your website is being hosted, so that that isn't an issue. I think I'm through the list of questions. Oh, yeah. Okay, one more question I think is coming in. I'm being passed these, so I'm not really following the chat. Apologize for that. Okay, so from a high level, how would you implement U2F authentication in the Windows logon process? That's a good question. So you can do, so when you're talking about Windows login, I mean, there's local login, which is just authenticating to the machine itself, or you could do authenticating to some server on the network. In either case, you would have to implement you would have to modify the login so that it can speak to the device over USB. It would have to implement the things that the FIDO client implements, just like the Android demo I showed. And you would have to figure out what to do with app IDs and origins, because well, on the web it's pretty clearly defined that the origin is the domain name and the protocol, but that's not really applicable outside of a browser. So as long as you can come up with something, and it doesn't really matter what it is, but the FIDO client just needs to know how to determine if the origin is valid for the specific app ID. Then you would have either the local machine or the server authenticating to generate the challenge, do all the things the server did in the slides I showed, send that to the machine and perform the same steps as the browser does in Chrome. And then you would verify that by verifying the signature, either, again, on the local machine, if that's what you're authenticating to, or to the domain controller or whatever. Okay, one more question. Is it possible to use U2F in a command line, for example, SSH? So for this to be a good user experience, you need to modify probably both the server needs to support it and the client needs to support it. So the client needs to communicate with the USB device and know what to do with the data it's getting from the server and the device. The server needs to know to ask for this information and to know how to verify it. So I mean, it's definitely possible. There just isn't a great integration for it yet. There is a U2F PAM module that we have, which does things over text, really. So you're kind of copying and pasting things. So you're manually taking that challenge and sending it to a command that you're running locally that talks to your U2F device, and then you're taking the output of that and kind of pasting it back. So it can definitely be done, but it's if you want good usability, you're going to have to modify the client on a deeper level as well as the server. All right. Thank you, everyone. We're out of time. Thanks for your questions, and thanks for for watching.
Thank you, everyone. We will be sending a copy of the webinar, video format.